The average income in the United States looks very different depending on whether you use the mean or the median. The mean is pulled upward by billionaires, making the typical American appear wealthier than they are. The median tells a more honest story. Choosing the wrong measure of central tendency is not just a statistical error. It is a way of telling a misleading story with true numbers. The mean is the arithmetic average. Add up all the scores and divide by the number of scores. It is the most commonly used measure of central tendency and has useful mathematical properties, including its role in calculating variance and standard deviation. However, the mean has a critical weakness. It is highly sensitive to extreme scores called outliers. A single billionaire in a neighborhood of middle-income earners will dramatically raise the mean income, creating a misleading picture of typical wealth. When distributions are skewed or contain outliers, the mean is a poor summary of what is typical. The median is the middle value when scores are arranged from lowest to highest. If there is an even number of scores, the median is the average of the two middle values. The median is resistant to outliers. A single extreme value at either end cannot shift the median far from the center of the distribution. This makes it the preferred measure of central tendency for skewed distributions and for variables with extreme values, such as income, housing prices, and reaction times. When the mean and median diverge substantially, it signals skew in the distribution. The mode is the value that appears most frequently in a data set. A distribution can be unimodal with one peak, bimodal with two peaks, or multimodal with more than two. The mode is the only measure of central tendency that can be used with categorical, non-numerical data. The mode of a distribution of favorite colors or political affiliations is meaningful, while the mean and median are not. The mode is often less useful than the mean or median for numerical data because it can be unrepresentative of the distribution as a whole. In a perfectly symmetric distribution, the mean, median, and mode all coincide at the center. When a distribution is skewed, these measures diverge in predictable ways. Positive skew, where the tail extends to the right, is caused by a minority of very high scores that pull the mean upward above the median. Income and reaction time distributions are classic examples of positive skew. Negative skew, where the tail extends to the left, is caused by a minority of very low scores that pull the mean below the median. Exam scores on an easy test often show negative skew. The range is the simplest measure of variability. Subtract the lowest score from the highest score. It describes the total span of the distribution. The range is easy to calculate, but has a serious limitation. It depends entirely on only two scores, the extremes, and is therefore highly sensitive to outliers. A single unusually high or low score can dramatically inflate the range, making it an unreliable measure of typical variability. The range tells you nothing about how the scores in the middle of the distribution are spread. The standard deviation is the most important and widely used measure of variability. It represents the average distance of scores from the mean, how spread out the distribution is. A small standard deviation means scores are tightly clustered around the mean. A large standard deviation means they are widely dispersed. In a normal distribution, about 68% of scores fall within one standard deviation of the mean, 95% within two standard deviations, and 99.7% within three. The standard deviation is the foundation for z-scores and for most inferential statistical tests. The normal distribution is a theoretical probability distribution that is symmetrical and bell-shaped, completely defined by two parameters, the mean and the standard deviation. Enormous numbers of psychological variables, including IQ, height, standardized test scores, and many personality measures, follow approximately normal distributions in large samples. The normal distribution has important mathematical properties that make it central to statistical inference. The empirical rule specifies the percentage of scores that fall within each standard deviation band of the mean. A z-score transforms a raw score into a standardized unit that expresses how many standard deviations the score falls above or below the mean of its distribution. The formula is z equals the score minus the mean, divided by the standard deviation. A z-score of positive 2 means the score is 2 standard deviations above the mean. A z-score of negative 1 means 1 standard deviation below. Z-scores allow meaningful comparison across different tests with different scales. Knowing someone scored at a z-score of plus 1.5 on both a math test and a reading test tells you they are equally above average on both. A percentile rank tells you the percentage of people in the reference group who scored at or below a given score. A score at the 50th percentile is right at the median. Half the reference group scored below. A score at the 95th percentile means the person outperformed 95% of the reference group. Percentile ranks are used extensively in reporting standardized test results because they communicate relative standing intuitively. They are not the same as percentage correct. A score of 60% correct on a difficult test might place a student at the 80th percentile. Effect size measures the practical or clinical significance of a difference, not just its statistical significance. The most common effect size measure is Cohen's d, which expresses the difference between two means in standard deviation units, equivalent to a z-score for group differences. A Cohen's d of 0.2 is considered small, 0.5 is medium, and 0.8 is large. A study with a large sample can find a statistically significant but trivially small effect. Reporting effect sizes alongside p-values is now standard practice in psychology because significance testing alone cannot tell you whether a difference matters in the real world. Statistics are the language of evidence in psychology. Choosing between mean and median, understanding what a standard deviation tells you, and knowing what a z-score means are not just test skills. They are the foundation for evaluating any claim that depends on data. Every headline about a new study makes more or less sense depending on whether you can parse the statistics behind it.